We start off with investing $1,000 in a 5-year savings account with a fixed annual interest rate R with monthly compounding. The amount of money A in the account after 5 years, or 60 months, is the following. A of R equals 1,000 times 1 plus R over 12 to the 60th. This is based on the formula for compound interest. And our goal is to have $1,400 in the account after 5 years. And we need to use the intermediate value theorem to show there is a value of R in the interval from 0 to 0.08, for which A of R equals $1,400. Alright, so what does that mean? I want to find out that if I take $1,000 and invest it for 5 years, is there an interest rate that will allow me to basically make $400 in that 5 years, or grow my money from 1,000 to 1,400. So I do know that this is an exponential function, and exponential functions are continuous. We need to know that the intermediate value theorem applies. The next thing I'm going to do is I need to evaluate the function. I want to find A of 0. Right? Basically, I'm evaluating the function at my endpoints in A of 0.08. And I don't want to plug this in by hand. I want to use the calculator to do the work here. So what I'm going to do is I'm going to enter this function into my y equals on the graphing calculator. So I'm going to go into y equals. I'm going to clear out any functions that were there, and I'm going to type in the 1,000, open parentheses, 1 plus, we'll use x instead of r, so x divided by 12, close the parenthesis and use the caret key and raise that to the 60. Now I'm going to quit out of this, second quit, and I just want to evaluate. Now you can use a table here, but I'm going to refresh your memory on how to use the vars key. I just want to evaluate this for two different values, for 0 and for 0.08. So I'm going to hit the vars button and go over to yvars and function, since that's what we're dealing with. And we're dealing with the function that's in y1, so I hit enter. I want to evaluate my function for 0, and I get 1,000, which makes sense. Basically we're saying if I invested money at an interest rate of 0, after 5 years I would still have the $1,000. I wouldn't make any money at all. And then we want to use the y1 key again and evaluate it at 0.08, and I can just hit second. If I hit second enter, I can arrow back, just hit the back arrow key and put in a new value and hit enter, and I get 1489.84. So I can see that the y value that corresponds to 0 is 1,000. The y value that corresponds to 0.08 is 1489. And what I was looking for is to find out if my y value, and that y value is the 1,400. Since 1,400 falls between 1,000 and 1489, it means that there is some interest rate such that I could turn my $1,000 into $1,400 after 5 years. Just a reminder, you can also go into the table, and we'll just delete what was ever in there. I've got an x value and a y1. We can evaluate by hitting 0 and by evaluating 0.08, and we get the same two values. We get the 1489.80 and the 1,000 for 0. Since my a sub 0 is 1,000 and my a of 0.08 is 1489, I've really shown that this can happen. Now, if I want to estimate the interest rate required to reach my goal, I'm going to go in and graph this. I'm going to quit out of here. I've already got the function in my y equals. Now I have to figure out a good window. I want to graph that, and I'm going to go in and change my window. And since the smallest value I need is 0, I'll start with 0. The largest value is 0.08. I'm going to go a little bit beyond 0.08 and go to 0.1. My smallest y value is 1,000, and my largest y value is 1489. So let's just go to 1,500 on the y value, my largest y. And I just make the scale 100. The scale is not really that important in these problems. It's just what every tick mark is going to be worth. Now I'm going to graph that. And the reason why that is not showing up is because the equal sign wasn't highlighted. So I'm going to arrow over, put my toggle over the equal sign and hit enter. And now hit graph, and that should show up. Alright, what I want to do here is I want to find out, is there a place where this function is equal to 1400? And, well, I know it exists, but I want to try and find out where it exists. So what I can do is graph the function y equals 1400, graph that constant function, and find out where they intersect. So I can solve this simultaneous equation by using the calculator. So I'll show you how to do that. What I first want to do is I want to trace near the value. So I hit the trace button, and I'm going to arrow as close to that intersection point as I can, and I'm going to go get a little bit to the left of it. Let's see. Alright, I'm going to hit second, calculate, and you'll see this at 5, that means the intersection. And so the calculator asks me if I'm on the first curve, which I am. So I hit enter, and then it asks me, am I on the second curve? And I am. I'm now on the horizontal line. I hit enter. The last question is it asks you for a guess. You do not have to guess, just hit enter. And as long as you're close to the intersection point, the calculator will find that value for you. So approximately, the x value is approximately 0.067. And so it's approximately 6.7%. So R is the interest rate. In the problem it's a decimal, but we convert it back to an interest rate. So our interest rate is approximately 6.7%. That's the interest rate that we would need to grow $1,000 to $1,400 in 5 years.